All right, so welcome back to Pandas tutorial today. I'm planning to divide this today's session into two parts. So initial 30 minutes will be on Pandas, okay? Then remaining 30 minutes will be talking about machine learning and data science. We'll go back to the Titanic data set, okay? So Pandas tutorial, this is a very light topic. So we should be able to complete in 30 minutes, okay? So you should please open a new worksheet, I mean a new Jupyter notebook. We should not mix up with that Titanic dataset worksheet, okay? Let us open a new worksheet here, I mean new Jupyter notebook. So I will explain, there are so many commands in Panda that we should be knowing because to go ahead with this Titanic dataset, we will be using those commands. Okay, take this particular data. It will be easy for you guys. So here I'm trying to show you how we can create a data frame. Data frame is nothing but Excel sheet or SQL tables, right? So I have three lists here: name, weight, and height. All these are related, okay? For Basu, height, weight is this, height is this, like that, okay? So here that is how we create the data frame using a dictionary. This is dictionary, right? You have this brackets, name is the key, then this name is basically this one, right? This list, likewise you have height and height, weight and weight. So this will create a data frame. Are you getting it? Use this command. That is how we can create a data frame using dictionary. Okay. Done, Mina?
Yes, Basu, done.
Yeah, every command from here is important, okay?
Okay.
So this 1, 0, 1, 2, 3, 4, 5, 6, 7 are basically your row number, okay? This is basically an index. This is called default and index of this particular data frame. Okay, this is data frame, right? 0, 1, 2, 3, whatever is given here is coming from that system, and this is the default data index of this data frame. And these are columns: name, height, and weight. These are basically columns or features. And there is another term for this. This is known as label also, okay? L-A-B-A, label, okay? So you have 8 records here and 3 columns and 1 index. Index is this 0, 1, 0, 2, 7. You can check the data types of this particular data frames. You have object. Object is basically the string. Then height is a float 64. Weight is integer 64. You can change this. You can change it to integer 32 or integer 8. Okay. Now, head, this command is important. If I want to show the top 5 records of the data frame, this is the command. By default, it is 5. Otherwise, you can mention here 5, 10 like that. Okay. By default, it is 5. You can change it to something else, like whatever you want, like 10. You get 10 records. We don't have 10 records. I want to see only 1 record. I can have 1 here. By default, it is 5. Okay. By default, it is 5. This one is tail. Tail means last bottom 5 records. You can see the bottom 5, right? So likewise, you can change this number. And this one is interesting. df.sample means from the data frame picked up randomly 5 records, or any, you give any number here, it will change. Okay, it will pick up randomly 5 records from the data frame. All right, df sample. Okay, then we have columns. Column is basically name, height, and weight. You can check this one. These are the columns. Values means all is value. Okay, Sepia, Abasu, data frame values. All these values without columns is called value. Okay, this one, values, all values. There is no column or index here. Okay. Then index, it will show me the index only.
Basu, what is that d type is equal to object seeing in df.columns?
Data type. This
Yes,
one
object. Yes, yes.
is talking about this. This is string, right?
Oh, okay. So
It's
the
a string.
complete thing it is saying it as object.
Yeah, this data type of this return result. Okay, this is string, right?
Okay, okay, fine.
Name, height, all the strings. So it is called object.
Okay.
Data type object. So here also you see object. Okay. Index, it starting from 0, stopping at 8. That is what this one. This is index, right? 0 to 7. It will start from 0 and stop at 8. 8 is actually exclusive, excluding 8. Okay, then the data, this will show you the data. Okay, that we have already seen. Okay, here also we can have numbers. How many numbers you want to see? Bracketed numbers you can give here. Okay, no, yeah, bracketed number also. No, number not allowed here. Okay. This one is important, information about the data, about the columns, about the features, different data type, then whether there any null values and missing data. So it will show up here. Name is a column, number of records 8, all is at 8, number of records 8 is number of records, that non-null. Non-null. We don't know any. There is no null values here. Okay, only 8. There is no null value here. 8 we are saying. Yeah, describe we have not seen yet. This is important as part of data analysis. This is statistical information. Okay, it will show up only for numerical features. The numerical features. What features we have? We have only height and weight, right? Only these two we have, no? Height and weight. We have only these two, right? Only these two are numbers. Only these two are numbers, right? Height and weight. So statistical information will be for those numerical features only. It will show how many records are there. What is the mean? Mean means average, okay? Mean of that particular feature. Standard deviation. You know standard deviation? No, right? You have, I think, this. Did we study the standard deviation in school? Yeah, we studied, but long ago. Okay, fine. We'll discuss about this in our statistics class. Okay. Min means minimum. Yeah, this 1, 2, 3, 4. Including these ones, the 5. 1, 2, up from min 25, 50%, 75%, and max. These are known as percentile. Okay. Then we'll discuss about this. This is known as a 5-point analysis. Okay. Or this is also known as Whisker bottle analysis. We'll discuss about this later on, not today. Okay. This is for this command we have seen yesterday to check how many null values we have. Okay.
Yes.
Is null. Then I'm just checking the data again. Then yeah, sorting. If you want to sort the data on specific axis, you can do it. This is the command. Sort underscore index. X is equal to 0. It's not that important actually. This one is important, this one. This command. This will be sorting on the particular column by then column name. This command is important, okay? This command is important. Sort underscore values. You have noted, right, Mina?
Yes, Basu. Okay.
Okay.
But above one, based on what it is sorting, above this, yeah, this one, axis 0. What is axis?
Yeah, index is this, right?
Okay.
But this is useless actually. See, this index can be changed. Supposing here I can have this name also here in this index as part of index. Okay, I can convert this column into index.
Okay.
So you can sort on this index, and x is 0 means this direction.
Okay.
Top
Yes.
to bottom.
Column.
Yeah.
Yeah.
X is 0 means top to bottom. That we have seen right in NumPy.
Okay. Yes.
Top to bottom. So here it is already sorted. It is meaningless actually. But if you have something like this, you converted this particular column into index. So this will go away and it will come here. Then if you sort it, then it gives some meaning, okay? Normally, we don't use this one, but except in few cases like time series analysis, we might be using this this column coming as part of index. That
Okay.
only few cases. Normally we don't use it. Okay, but this one is useful. Sort by values, sort underscore values by column name. You can have multiple column here like this, but you have to put everything in a list. Is there a list, right? So you can put it in a list and have multiple columns out there. So this is in order like height, then weight. In this order, it will be sorted. Okay.
So in list, what will be the sequence? Like how will it sort? Like it will first it will pick the height and then it will take the weight and then sort according to that because usually I mean I understand that the sorting is based on one criteria or something, right?
Yeah, first this will be sorted on this, okay, height, like 1.2, 1.2. See, 2 times it is coming, right? Okay. In the second case, weight, then it will be sorting on this particular column, like 49 is coming
Okay,
first.
okay. Yeah,
It is
yeah,
coming
yeah,
first,
got it.
right? Yeah. If you swap this, you will see something else. Like you try, you swap this one. Control F.
Okay,
Yeah, put it
okay.
here in the first order. Then what it will do, first it will sort on weight. What is the lowest one? Weight 49, 49. Yeah, this 49 will be there. Then 49, how many we have? 2. Then we have 1.2 and 1.6. So this Tuesday will come up here. Okay.
Yeah, right.
Yes.
So like I have 1.2 height and then I have
Mm.
1.6 and then I have 1.2 again because it's
Yeah.
50, right? And 14 to
Yeah.
49.
Correct.
Yeah, so yeah, exactly.
Mm. First, this should be sorted on this, then it will be sorted on the second in this order. Okay. This one is, this particular command is very, very important. Useful actually. Very, very useful. Right. And Yeah, this one is like if you want to access particular column of this data frame, this is a syntax. Remember the syntax. Syntax is very important. Okay. Very easy to remember, but very important. The same thing like df, this bracket, then this and this. We have actually equivalent command for this. You can have df dot name. This were same. This were same. Okay. This were same. Then you can access like this. This is row access, like we have seen in where? We have seen NumPy, right?
Yes.
We have seen in NumPy. From 0 to 3 means 0 to 2, right? 3 is not included, right? 3 minus 1. This is start and stop. Stop minus 1. So 0, 1, 2. All right. Yeah. No. See, we have seen here, right? We have seen this command here. This is, remember, this is only for a single command, single column. If I want more than one column like this, okay, I want to see two columns. So this command will not work, okay? Like I say name, comma, height. This is not going to work. This is not a syntax. Remember this, okay? This will fail. It's not correct. Okay, so don't remember this. This is not correct. Correct one is this one. You have to access by level or access by location. Now let us try to understand what do I mean, what do you mean by access by level? These are also known as labels, okay? These column names, name, height, weight, these are also known as labels, okay? So if you want to access more than two columns, you have to use the syntax access by level LOC. This LOC, okay? df dot LOC means I am going to access the record by level. Then the rows, I am going to select all the rows, okay? This indicates all the rows, right? First, the semicolon indicates all the rows, comma, and the label names. I have two labels, name and weight, right? That is it. You can access this way also. This one. Okay, but there is a difference. You'll get to know, okay? Better remember this one. This is like universal. You can use it for so many purposes. This is, we are just selecting the rows without any conditions, and we are picking up only two columns, two levels, okay? There is no condition. Supposing I want to select only those rows which are having weight equal to 60 or weight equal to higher than 50. This command, this cannot handle. This command cannot handle. I mean, this format will not cannot handle that kind of queries. But this format will handle with little modification. Okay, that is why remember only this one. Remember this format only, this particular syntax. This is so useful. Okay, so to select multiple columns or levels, this is the syntax you should remember, and this is using level. Level means this columns, right? Now there is something called accessing by location. Location is this, like if you don't want to use levels, these are called locations. Okay, what is this location of this row? This is 0, right? What is the location of this level? 0, right?
Yes.
What is the location of this height? Row 0, column 1. So I can access this element. I've got two ways, either by location or by level. So here we'll see how you can access the records using location. This actually we have seen many times in NumPy. This is same as in NumPy, okay? There is no difference here. This is same as in a NumPy. It's all 0 to 3 rows, when 0 to 2, and all columns, right? I have not specified anything on columns. So it will select all the columns, but 0 to 3 rows only. You will get only 3 rows. Similarly, same thing, no difference here. This is the ultimate one, okay? What we are trying to do here is, this is select accessing by location, right? I have given I here. By I means by location, okay? So which are the rows that I'm going to select? I'm going to select row number 1, row number 3, row number 5. Then comma, this part is, this component is for columns, okay? So column number 1 and column number 2. As simple as that, right? Let's see. Our data was like this, huh? Original data was like this. I have selected what? 1, 3, 5. 1, 3 means Meena, 3 Hasmit, 5 Sabya. Then 1, 2. Only 1, 2 column.
Yeah, why is name excluded here? Name is not there.
A name we have not selected, right? Here, then you need to select the names here. 0.
Oh, column. Okay, fine.
Yeah. You select, you'll get name. See, name has come.
Yeah, I got it.
I got it.
Yes.
This part, second list is for columns, okay? First list is for rows. Okay. So this is not dynamic here, right? This is a very, very static selection, right? Slicing. Very, very static slicing. Now, if I want to do this dynamically, there are ways to do that, okay? We'll see it. It's like we will be writing a query, like a SQL query, okay? And select the rows and columns. We'll do it, okay? Now, here comes, okay? Here it is coming here, like Boolean indexing. Okay. The types, okay, oh, no, we don't need this one. I'll remove this one. Yeah, this is the one, you see. Okay, let me remove the outer one and see. This is like a Boolean statement, right? This is not like, it's a Boolean statement. What we are saying is, select all the rows where height is less than 50, right? This is the query. This is the query that you need to write. Remember this query, okay? df is data frame, bracket, then the column name, then bracket close, then condition less than 50 means height less than 50. Or you can have anything here, like equal to, or greater than, blah, blah. Okay, whatever condition you need to have, you can write it here. All Boolean conditions you can write here. So in this case, it is height less than equal to, select, show me all the rows with height equal to less than 50. Now see, this will return only true and false. We said Boolean indexing, right? Now, once I have this Boolean data true and false, now it is easy for me to get the data, right? I will use this Boolean data in the same data frame and get the records. df is the data frame, then this is a syntax, then close it, you will get the rows. Wherever it is true, you will get the all are true less than 50. Eh?
Because
Yeah,
people are with 1 point.
let us take weight, na?
Yeah, wait.
Weight should be good, na? Yeah, let us take weight. So, if, yeah, let's see. See, you will get only two records, number 4 and number 7. Only 2 are true, okay? So let us have, you need to have another DFA data frame, then bracket, then this bracket. This is the syntax, okay? Remember this. This is the syntax. You are getting only this, right? 49, 49. Got it?
Yes.
Yeah. Let's say less than 60, okay? Let's say less than 65. You get almost everyone except one. Okay. Now this is only one condition. If I have more condition like this one, another condition, you have to write the same structure within that. Okay. This. Then I say height. Height is suppose what a condition I need to make. Suppose height is greater than 1.2. Supposing 1.2. So this is not a syntax. What is you are supposed to have this an operator, okay? Then you need to have a bracket here, this bracket, and close this bracket. Again, open one bracket here, close the bracket again. Okay, this is the syntax. Okay, this is the syntax. So remember, before having this AND operator, you have to have actually this brackets, open bracket and close brackets. So if I have three conditions, you will have like that, and bracket, open bracket, close bracket. Okay. This is exactly like your SQL query. Okay. Got it? Hmm? Understood, Mina?
Yes, Basu. Got it.
Okay. Now, this is like I have hard coded here. This can be dynamic. Okay. This part can be dynamic. You can dynamically write this one. Okay. Like this condition can be written dynamically. This part, this one. Height equal to something, weight equal to something. You can have a variable out there outside this. Let's say what is this? W equal to, suppose I say 65. Okay, let's say 65. Then h equal to, suppose the same thing, 1.2.2, right? You can put it here. W, then you can have here h. There's the syntax error, right? You get the same effect. Okay. In fact, entire this part you can frame a sentence outside this. Okay, outside this command you can frame this part, entire this part, this one, this one, this one. You can have this particular part of this command outside of this, then you can use that variable and put it here. It will work. Okay. So this is how we write the query. Okay. There is another is in, like if you have multiple, like this in command, write in SQL statement, Meena,
Yes,
where
Basu.
this equal to in this blah blah, same thing, same thing. This is like your in command. in SQL. In SQL query, same as in comma, this is this one. Okay, 35 over here. Okay. Then, yeah, this is note down this one. These are actually very useful in day-to-day data science activities. You will be writing all these commands. This one, these two are so important. Okay, these two queries. All these are queries. Then now we'll talk about like creating a new column. Suppose I have data frame already. Okay, I have this data frame. I want to have another column here, another features. How do I do it? That is what we are going to talk about now. So I have a list, gender equal to M, F, blah, 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 blah. I have. This is corresponding to this particular data frame. So I have 8 records. So here also I have 8 members in the list. This is my, so I want to have gender here, another column here, okay? It will come up here, next column. So gender is a list here. So I can create a new column gender using the gender list. And this is a syntax, okay? Remember this. Now, many times you will be using this syntax. Many times, okay? You see now, you have another column here, see? Okay. That is how you create a new, okay, I think I call, okay. That's how we create a new column. Suppose I want to create a column by computing something here in the existing column itself. I can do it. It can have arithmetical kind of calculation out here. Suppose I want to derive columns. Let's say BMI. What is the formula for BMI? Any idea? Something, right? Height divided by weight divided by height, something, right?
Yes.
Some square something is there. Or let's say just we'll divide, okay? df, comma, I want to divide weight divided by df dot height. This is basically a derived column, right? From these two existing column, I'm deriving another column, new features, which is named as BMI, okay? So I will have another column here. And I have a logic. This is a logic, okay? This is a logic, right? Suppose this is the logic. This is also very useful in machine learning. This command is also very useful in machine learning. Okay, let us run this and see what happens. Come on, I have run. Let's see what is the output. I'm getting another column here, see? Right, all right. Okay. Now, if I want to assign directly to a particular cell number, cell means particular row and particular column, I mean either of this, I can use this particular command, this one. Like iloc, what is I? I stands for location, right? I stand for location. So I'm using iloc command to point to that particular cell to update. So 0 means this row, comma 2 means column number 2. So this is 0, 1 and 2. I'm talking about this. So this 65 should be now 64. Let me change it to 90 or 100, okay? So we should get 100 here. 65 should be 100. Yeah, this is same as what we did in NumPy. Okay. Got it? We still have, let's see. Okay, I'll go ahead. Then missing data, this, okay, this is also we have seen, but we have not used any command yet. This we have seen yesterday, like there are so many cabin numbers missing, age is missing. Then there are two cases, I think, where we don't have seen that point of embarkment, right? So that is how, let's see how to handle missing data. I'm creating a dummy missing data here. So I lock 0 and 2 means the same location that we have changed here, right? 100. Now I should be saying none. I'm allocating the np dot none means missing data. Okay, it will be none. Let's see whether we get it now. See, now it is missing. Data is missing, right? There is no data here. So let us handle that, how to access this, how to see this, where it is. I'm taking a copy of this because I'm going to manipulate. So I have taken a copy of this particular data frame, and this is the command. Copy of data frame. Copy the data frame. Okay. This is how we'll copy the data frame. This is the command. This is same as in NumPy. Same command. Okay, now if I want to drop that particular row where there is missing data, like this one, I can drop the row like this. So important command, guys, this one. Drop any mean missing data. How? Any. Wherever you encounter missing data, drop that particular row. That is the command of this. This basically it will drop the row. Drop rows. Whenever you encounter any missing data, you drop that row. That is the command. It will drop now this one. It is drop and it's not showing up here, right? If you see this, see the description of this function method. Remove missing values. X is equal to 0, how any, this is a default parameter. Now this one is important. In place equal to false by default. Okay, that means it is showing here like it is drop, but actually it is not drop. Okay, it is still there. It's not committed. If you want to commit, you need to have this command here, in place equal to true. By default it is false. Okay, in place equal to true, it will drop then commit, right? Now let's see, I'm dropping as well as I'm committing. Huh?
You have to call df2.
Ah, yeah, df2, no? Correct. Now it will commit, okay? So this is important, this command. Like normally what we do is, first time we will not have this command and see whether my command is correct or not. If we are sure that it is correct, then only I will have this, in place equal to true, to commit, okay? So by default it is false. If you want to commit, then only you should have this command, in place equal to true. Okay. So the draw is gone now. Okay, the draw is gone. Now fill any will not be possible. No. Okay. I've already dropped now. Let me copy it.
We can take the data frame, other data frame, right? Copy
I'll
it one before.
let me copy again now. And let me copy again here. Okay. df2 equal to again df dot copy, right? I'll copy again. Yeah. Now df2 me I should have the entire thing. Yeah. Now it has come back. Suppose I don't want to drop. Okay. I don't want to drop none values, none records, but I want to replace none with some numbers. So you should use this command df2 dot fill na. This NA is the main thing. You are filling all NAs, okay? Wherever it is, I'll fill with this particular value. Say it is filled with 90, okay? 90 has come here. Here 90. Now, similar scenario, it doesn't commit, like it doesn't commit, okay? It's not committing df2, right? df2, it doesn't commit, it's not commit. Still it is there. So if you want to commit, same thing, in place equal to true, not true. Place equal to true. Okay. Now this will commit. Now 90. NA is gone. Okay. Right. Remember this command. The same thing. That is what I did. Okay. You don't need this now. This is not required. Ah. Yes. Any question, guys?
Can you go
No.
up? Yeah, that one.
Tripoli?
No, that
Fine, right?
Filna is not working for me.
Is it? Fill NA.
Yes, fill NA.
Fill
Value
NA.
is also 90.
What is that error that you are getting?
No, not reflecting the value.
Hmm. Did you? Uh, you have any values, right? Any is there?
Yes, yes,
None.
yeah,
But you are not able to replace it.
yes.
You have put in place equal to true.
No, that you
Put
have
that.
to put.
Yes,
Okay,
yes. Whenever you want to commit, right? You need to
okay.
put there in place equal to true. You have to have this command. This particular parameter you should have in place equal to true.
Yeah. Now reflecting.
Now it will commit. Okay.
Yeah.
Yes. Okay. Then this is same as what we did. Like this is like is null. Okay. This is like is null only. Okay. Is na. So this is okay. Is null. This is same as is null. Okay. We have seen already, right? Is null. This is same as is null. In null is null. Is null function. Same as is null. Hmm. Okay, now let's talk about the statistics. Okay, see, this statement is important here. Operations in general exclude missing data. Means though we have missing data, it will go on calculating and giving the result. It will exclude. If there is any null value, it will not calculate. It will just remove that rows. Then it will go ahead and calculate the data. Calculate the and get the result. Okay. Like I'm calculating a mean. Mean means average. X is equal to 0 means column wise, right? This is column wise. So height, the mean is 1.5. Weight is 51.57. BMI is 36.04. All this. Okay, it is on column. This is will be on rows. You'll have eight rows here. You'll get 8 rows. row wise, right? Same as we have done in NumPy. When you say 0, means like this, from top to bottom, it will calculate. When you say 1, it will be like from left to right, right? Left to right. So all this none and this character, which is basically categorical data, will not be considered for calculation. Like here, name, gender will not be considered for calculations. Okay, it will ignore automatically. Min, okay, that's okay. This is, yeah, this direction. X is 1. Okay, now, yeah, this is a very useful method. This you can apply on entire data frame, or you can apply this particular command on a specific column. Okay, so I have this data frame, right? Now using this apply command, I want to create a new column here, and I'm using a function. I'm using a lambda function. Okay, I'm using a lambda function on column height. Height means this. I'm taking square of that height. Okay, for each and every row, I'm applying this particular function. You can have your own function here. I have just written lambda. You can write your own function and use it here. Okay, with some logic, like complicated logic, you can write in that function, use a defined function and use it here. Here I have used only lambda. I'll show you how you can define your own function and use it here. So what this function here is, it will take height, then it will take square of it, and it will square up height. Okay, that is what it is going to do, and you will have a new column here. Remember this apply. That is what we will be doing actually in Titanic dataset also. We are going to use this function. Okay, it is done. Let's see. Right? Square of this is this. Square of 1.2 is 1.44. Right? So this apply is very useful. Very handy. So let's say you can define, same thing you can define, right? You can define like this, def sqr, so some value we are getting, right? Then return x2, right? External 2, that's it, one line command. So let me copy this one. I'll remove this hash. Instead of lambda, I will have my own function here, sqr. Okay. So let me have this new sqr. Okay. So this we have defined our own function. Let me compile this one, run this one, then this, run this, and let's see whether we are getting or not. We got it, right? Same value we got, right? Akanksha.
Yes, yeah.
Is it okay?
Mm-hmm.
So this will be useful. I'm telling you guys, in our data set, Titanic data set, definitely we need this apply function. We need to use this function. That is what I have already seen. We will be using this. We'll be using this for one particular column there, particular feature. We have to use. This is useful to extract data or you want to extend, we call it data manipulation. No, not data manipulation, features engineering, right? We call it feature engineering. That time you might be using this particular function. Okay, done. This is very, very useful. Okay, we have 4 more minutes, right? Meena, we have meeting, na? 4 o'clock.
Yes, Basu. 4 we have it.
Okay. Okay. So you get the merging like we have seen, right? In NumPy, we have seen vertical stack, horizontal stack, concatenation, those things we have seen. Similar thing we can do here. Okay, like concat is basically, is it a vertical stack or horizontal stack? It's a vertical stack, right? Vertical stacking. So same thing we can do it for testing purpose. Just to showcase what I have done is I have taken 0 to 2 means 0, 1, and these two rows 0 and 1. Okay, then another slicing what I have done is 6 to 8. 6 to 8 means 6 to 7. Okay, so I'm combining these two row or these two data sets, I mean slice data sets. So I have 0, 1, then 6, 7. From this command I should get 4 rows, right? See, this first command will give me 0 to 2. 0 to 2 means 0 and 1. Second will give me 6 to 8. 6, 7. There is no 8. So I will get 6 and 7, right? So I will get 4 rows. Stack. It's a vertical stack. Okay. It's a vertical stack. Right?
We can also do this using that ILOC, right? Like TF 1, 2.
Yeah, here,
So,
right? Yeah. This slicing is up to you, which particular technique you want to use, okay?
okay.
This command needs only similar dimension. That slicing, whatever you are doing here, you should have a similar dimension. Here we are having what 2 by 4, 2 by, not exactly. The column should be matching. Okay, number of columns should be matching, and then you can do this. Anything you can use ilog, you can use lock or anything. Ilog or lock. So this is called concatenation, concat command, but there is something called join. It is simply without any condition, it is stacking one after the other. But sometimes we want to join side by side, right? I mean, this is horizontal stacking, you know. Instead of stacking like this, these 2 rows, I want on the other side, this side, okay? On the right side. Then you can use the join command. Join command, it's not a command. Corresponding to this, we have command, this is called merge, okay? You can use merge command. Suppose I have, on the left side I have this, right side I have this. See, left I have this.
Okay.
Then right side I have this. Now look at it very carefully. I've got key. Key means it could be any column name, but data wise, I have same data here. See, Basu, Meena, Rupali, Basu, Meena, Rupali. Okay. I have height here and I have here cities. I want to join these two side by side so that Basu, height 2, city BLR, Meena, height 3, city BLR, Rupali, height 5, CT VBS means all this CT column should come here in this position. Okay, that is the idea of merging. There is a very simple command here like pd.merge left and right on what? On key. Okay,
So we are going to give the common feature. Based on that, it's going to
Right,
match.
right, right. Common feature. You should have common here. It should be matching.
Okay.
Position could be anywhere. Like Mina could come first here, then Drupal could be at the top, something like that. But it should have that data should be matching. Okay, so let's see, merge it. You have seen, right? City has come on the right side. City is here. Height is here.
We
Pathway.
have this in SQL join queries, right?
Yeah, skill join exactly. It's a join query. Yes.
Yeah.
So this is also very important because in data science normally we will not get only one data set. Like we have seen Titanic, there is only one data set, right? But in real life project, you'll see so many tables like we have seen. Nah? So you have to join those tables and get the record, get that information. So those things, if you have that kind of scenario, remember this merge. Okay, merge. This is the command. It is 4 o'clock already. Shall I stop now, guys?
Yes.
We'll stop now. I have very little, so these are not required for Titanic. Okay, so I'll stop. Then tomorrow we don't have, right? Tomorrow no class, right?
No, it's on Friday.
Friday we'll go back to Titanic. Okay, we will be using all the command that we have come across today. Okay, all these command we'll be using in Titanic data set. So let us stop for today. We'll join back on Friday again. Right? Okay
Okay.
then. Okay. 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 We'll stop here.
Um, bye bye. Bye. So
Bye
thank
bye.
you.
Okay. Bye. Thank you. Bye bye.
Bye.
Bye.